interesting that happens, and no one can really explain it. In many cases, people think it's like an over exaggeration with the way they speak. Okay, maybe it's a slur, and then once they speak over time, constantly, they pick up a rhythm where they believe that they're actually, have this accent when realistically it might just be a rhythm that they speak in from the damage or from the condition. So they might not have an accent, it just might be the way they speak from that condition, from that damage. Does that make sense? Yeah, but I think it's interesting anyway, especially when you take damage to the temporal lobe and when we know about the Wernicke's area, the Broca's area, and how that may affect people. Okay, next thing, page 162 to 165, we're going to talk about the hemisphere of the brain. Okay, so both hemispheres and how what kind of functions that both hemispheres have. Many people think this is a myth, right? That these different, if you're right-brained or left-brained, but there's some proof behind this thinking, though, which we'll talk about with split brain procedure today. So 162 to 165. I'm not sure what it would be on the PDF, but I'll figure it out. I'll find it. How do you find this so fast?
I read before, so I've been here.
Oh, in Discovery, you're like, oh, check it out, or what?
Yeah.
Okay. Let me say, every time you're like, oh, found it. You say 174.
Yeah.
Okay. Mine's slow. I'll get there sooner or later. Right, Rooster? Excuse my friend. He's a little slow. You ever see Dumb and Dumber? You have? Oh, my. Come on, man.
You've never seen Dumb and Dumber?
All right, so I'd like you guys to read Hemispheres of the Brain. I think that's what it's called. Yep, Hemisphere of the Brain. And that will continue on to 165. Shouldn't take you too long to do. So read that, check it out, and we'll talk about it and split brain procedure, how that can affect people. Uh-oh. All righty. Okay. So, like I said, with damage to the Broca's area, there could be results or strokes. Let's say, obviously with damages to the Broca's area, there could be symptoms like FAS, right? Foreign accent syndrome, which I think is pretty interesting. And where is speech mostly located, right or left hemisphere? So expressive language, where this Wernicke's area, Broca's area is located. What do we think? Katie? The left, yeah, good job, the left hemisphere. All right, so in your reading, you read about the left hemisphere, right hemisphere. So with the right hemisphere, what characteristics are located there in the right hemisphere? What type of functions, characteristics for the right hemisphere? So someone says you're right-brained. What does that mean? What does that mean if you're right-brained? Rooster, go ahead.
It helps like solve complex relations, and it's also like more. It helps more.
Good job. So creativity, right? Spatial features. Okay, we can view objects, things like that, and it's almost like based off emotion too, in a way. Okay, we're the right hemisphere. So artistic, right? Artistic ability, architecture. So if you're good at designing things, that might be another characteristic of if you're right-brained. So if anybody says you're right-brained, you're good at creating artwork. You're good at forming different shapes. Okay, things like that and understanding different types of really architecture. Okay, that's a good example. Okay, and if you're artistic, things like that. And if you're left brain, that means you are, you have rational thought, you have really good reasoning behind things, you're great with writing skills, okay, mathematical reasoning, okay, you're more of a, I guess, a traditional style of learning, okay, if that makes sense. So note taking, things like that. And if you're right brain, obviously, like you learn more with different types of visualization, pictures, things like that. That's a good example of the right and left brain. All right, so the corpus callosum. What is the corpus callosum? What was that? You guys read about that? You should have. What is the corpus callosum? Dom, go ahead.
It's like how the left one communicates with the hemisphere.
Yeah, good job. It's almost like a bridge, right? A bridge between the left and right hemisphere. And that allows for communication between the two hemispheres of the brain. And with the corpus callosum, which we'll talk about with split brain procedure, if that's cut, then there can't be really any communication between the two brains, the two hemispheres. Okay, in a way, you have two brains now. Okay, and it's hard to communicate different things. And if you're visualizing something and you're supposed to draw it out or express what that object is, depending on what side of the brain you visualize it on and see it, you might not be able to explain that object. You might not be able to express what you see. Okay, and if let's say you visualize in the left side of your brain, you can express what you saw. Okay, and vice versa. Right, and like I said before, if you take damage to, let's say, your right side of the brain, what side of the body is affected? If you take damage to the right side of your brain, what side of the body? Left side. Good job, because we know that it crosses over. Okay, so with the reading, I thought it was interesting. With split brain procedure, which we'll talk about. With split brain procedure, people do this because of epilepsy, right? Seizures and the severity of seizures. So in order to try to maybe stop these seizures from happening, reoccurring, or the severity of it, there's a process called split brain procedure where they cut the corpus callosum. In many ways, it actually works, right? In many ways, it works. It stops seizures from happening and the severity of it. And I think that's interesting. I wonder who's ever thought of that. Oh, you know what? Let's just cut the brain in half in a way. It's like, what? Whoever thought that would be a good idea? But in some cases, it works. But some problems with that moving forward with split brain procedure, like we talked about, what you read about, is that it's hard to communicate different things, what you visualize, what you feel, what you see. And I thought it was interesting at the bottom of the reading with the split brain procedure, they showed a picture of a naked woman or a naked person. And if they visualize in the left side of their brain, they could explain. They laughed about it. They're like, oh yeah, this is what I saw. This is, you know, the naked body, or then, you know, this person who's naked. But they visualized on the right side of the brain. They just kind of gave a grin. They're like, they couldn't explain what they just saw. They just could feel emotionally feel what they saw, but they couldn't explain what it was. And that just goes to show that the corpus callosum just expresses that bridge, that relationship, the communication between the two hemispheres, and why that's needed, why it's important, why it's significant. And you're going to watch a video here. I'm going to show it towards the end of class of a man that's doing some testing on a person that had split brain procedure, and that his corpus callosum was cut. And he has them visualize a picture. Okay, there's a dot in the middle, and if it shows up on the left side of the screen, he has to describe it and draw it out. Okay, and so he has two pictures actually. So in the one example, he has a hammer and a saw. Okay, and with the left side, he's like, hey, what do you see on the left side of that dot? And because it's being processed in the right side of the brain, he can't explain it, right? Because expressive language is processed on the left side, right? So he can't express what he just saw, but he could draw it out, right? Because we know spatial features, we know that of you know, artistic ability, things like that is focused on the right hemisphere. So he could draw this item out, and they're just like, hey, what did you saw on the left side of that dot? And he draws out a saw, and he looks at it and he's like, I saw a hammer. He goes, well, why did you draw a saw? And then it shouldn't be funny. I shouldn't laugh at it, but he just like looks at him like, looks at the screen, and then the guy that's doing the study just looks at him like, why did you, okay, whatever. It just shows that we have that communication and how what we draw, what we see, what we visualize, and in order to express what we saw and visualize and draw, once that cerebral or the corpus callosum is cut, we can't express what we visualize. And I think that's interesting. And that's a lot of problems with these people that have split brain procedure. Okay, it's hard for them to depict and see and observe and express what they just saw and visualized. Okay, here's just another example of that, which we'll talk about. So again, right, so he's focusing on the dot here. Okay, on the left side, we see a key. On the right side, we see a ring. So he picks up with his left hand, okay, which is processed in the right side of the brain. He's like, hey, what did you pick up? What did you pick up? And because he sees it on the right side, he says, oh, it's a ring. Now you're holding the key, man. What are you doing? What are you doing? And I think that's interesting. And again, you shouldn't laugh at it, but it's kind of hard not to in a way. Okay, so I'll show this video real quick. I think it's funny. Well, I don't think it's funny, but it's interesting. Oh, it's interesting. I'm sorry, Key. I can't help it.
Well, and that, you're very back and forth.
I know. I shouldn't laugh at it,
It's
but I
not
do.
funny, but like, I'm laughing at it.
Wait till you see it. Okay, you can't blame me.